Now that we understand some basics about how x's and y's and sines and cosines and all of that relate to each other, let's see if we can go ahead and graph out a sine function. When we're graphing this function, it's important to remember that it is circular. So if we start at 0, after we travel one full revolution around this circle, well, we're just going to hit all the same values again. So really, we just need to figure out what our graph looks like from 0 to 2 pi, and then it's just going to repeat itself. If we're going to do that, I know from earlier videos that if we're dealing with a unit circle, which I did pick a unit circle, y is just equal to our sine function. So if I want to know what the sine function is equal to, I can just look at the y coordinates. And the easiest y coordinates are going to be right here at my quarter marks. So what I'm going to go ahead and do is I'm going to graph out what's called a period here. I know that I'm going to start at 0, and then it's not going to repeat itself until it gets to 2 pi. So that's going to be one period. And then as I mentioned, we end up with really easy footholds to find if we just look at our quarter marks. So I'm going to cut this in half. And I know halfway in between 0 and 2 pi is just pi. And we can see that our y value at that moment is just 0. So I have one foothold there. And then I'm going to cut that in half again, which is going to put me right at pi over 2. And the y value there is up at 1. It's going to reach its maximum at that moment. And then I just need one more foothold. And I know that directly in between pi and 2 pi is 3 pi over 2. And if I look back to my unit circle, I can see that at that moment I'm at -1, or y equals -1. And then when I get all the way back around to 2 pi, I know I'm right back at 0 again. So now I have these 5 points, and that's actually enough for me to graph one full cycle of my sine wave. What we end up with is almost these things that look like parabolas. They're not, but that nice gentle curve there. That's one period. An important detail is noticing that the whole thing is oscillating above and below this kind of middle line here. And so we know that the middle of our parent function is just at y equals 0. That's going to become pretty important later because that might move when we get some transformations. In addition, we notice that it is going up and down by a constant amount. That's what's called the amplitude. So our graph is going to go one amplitude above and one amplitude below. And in this case, our amplitude is just 1. And the reason that our amplitude is 1 is if we look at all of our y values here, we can clearly see that all of our sine values are in between -1 and 1. That ends up being the range of sine. Eventually, you're going to just kind of have to remember this, but in reality, we can kind of see that we can normalize this a little bit more even. So one thing, we can make note that at our start and end points here, we're at the middle, or y equals 0 for this function. The middle can shift. In addition, we know that at our first quarter mark, we're at one amplitude above, or plus one amplitude, in this case plus 1. And at our third quarter mark, we're one amplitude below. And then the very last point, the only one not mentioned here, is the halfway point. And for the sine function, we're right back at the middle. All of that being said, you can notice that I figured all of that out from our unit circle. As you can see, the unit circle is kind of our Rosetta Stone for dealing with trig functions. It tells us where to look and how our function is going to behave at that moment. So I do encourage you to just have that in front of you whenever you're graphing so you can start to internalize this.